So, good evening, all. Am I audible? Bharatraj, good evening. Madhi, good evening. Kalki, good evening. Harichandan, good evening. Kishore, good evening. Am I audible? Yeah, thank you for your response, Nishant. Sadvika, good evening. Agala, good evening. Sanjit, good evening. Charan Kumar, thank you for your response. Yuva, good evening. Chandan, good evening. Shyam, thank you. Kavya, good evening. Okay, so thank you all for your response. So, this is Indra from Pantech E Learning. So, today is our second day of our 21 days masterclass on Raspberry Pi, right? So, today we are going to talk about complete guide on Raspberry Pi 4 pins. So, yesterday itself we already talk about the introduction part and how to install the OS and how to start Raspberry Pi, right? So, today we are going to talk about the pins. I mean Raspberry Pi 4 pins, okay? Okay, so let's start. So first, actually the Raspberry Pi 4 board has the GPIO header with 40 pins. In the comparison chart itself, we already know that. So after Raspberry Pi 2, everything has I think not I think there is 40 pins, right? So this GPIO header is so the same for Raspberry Pi 3 boards also. So this is compatible for 3 and 4. So this guide applies to both versions, right? So GPIOs allows you to easily use hardware features and communication like directly from a computer. So the Raspberry Pi microprocessor, the computer means microprocessor, right? So it brings the Raspberry Pi 4 much closer to hardware applications, making it perfect for being embedded in a hardware application or product like a robot, retro gaming applications, and there are so many things, etc. Right? So here I will break down all the pins of the GPIO header, and you will learn what you can do with them and what you can't do with them. Right? So let's start. So Raspberry Pi 4 pins overview. Here see, here is a complete overview with all the GPIOs and their primary function. So now let's break down each pin or group of pins and see what they can do. First, let's start with ground pin. Here you can see 9, 6, 14, 20, 25, 30, 34 and 39. There is 8 ground pins, right? So okay, so the ground is very useful for making a common reference between all components in your circuit. Always remember to connect all components to the ground. So if you connect two circuits together in the sense and a wire between both grounds to make it common. So if you add a new sensor or if you add an actuator to an existing circuit, connect the ground of the component to the ground of the circuit. This is the main thing. So that's very important. Without that, you may burn some parts of the circuit. You may have components that don't function correctly. Maybe it will give you the wrong values also. So you have to make sure of the ground part, right? Okay. And someone is asking like, can I use pen drive? No, you can't. Because you have to put that micro SD card into your Raspberry Pi, right? You can't insert a pen drive. You have to use micro SD card. You can't use pen drive, right? Okay. So see, here we have 8 ground which is of 40 GPIOs are connected to the ground, right? So you can find them with 3 letter. Here I mentioned it as G and D, which is nothing but ground. So let me give you one warning is that don't ever connect the ground directly to the power supply. It can be 3.3 volt or 5 volt. Here you can also see that, right? So this 2 is for 5 volt and this 2 is for 3.3 volt. So you should not connect the ground directly to the power supply. This creates a short circuit and can definitely burn your Raspberry Pi 4 board. So don't ever do that, right? And then we can talk about the power pins here. So you can find 2 pins bringing 3.3 volt and 2 pins bringing 5 volt. Here one is 2 and 4 and here 1 and 17, right? So those pins can be used to power components like such as sensors or like small actuators. So note that they are certainly not powerful enough to actuate motor, right? Such as servo or stepper motor. For that you will need an external power source. So the power pins are used as a source to power external components, not to power the Raspberry Pi itself from the external source, right? So well, there is a way to power the Raspberry Pi from the GPIO header, but you have a high probability of burning it. So just use the micro USB port. It's very safe, right? And then coming to these 2 pins, it mentioned as reserve, which is 27 and 28. So the pin 27 and the pin 28 are reserved pins. So they are actually usually used for I2C communication with EEPROM. I hope you know about the topic which is EEPROM, I hope. So if you just begin with Raspberry Pi 4 pins, don't connect anything to those pins. So there are many other available pins for you to use. So well, that's 14 slots already taken for what? Ground, power supply and reserved pins. So now let's see how the other 26 GPIOs are used for communication purpose, right? So now see, GPIO is nothing but general purpose input output. Okay, so basically that's one pin you can use to write data to external component, output, or you can read data external component which is nothing but input, right? So if you embed your Raspberry Pi board with some hardware components, the GPIO header will become quite useful. So GPIOs will allow you to read some basic sensor. For example, it can be infrared, ultrasonic, IR sensor, so many things, LDR sensor. And if you want to control some actuators which are working on like on or off model, so and communicate with other hardware boards. It can be another Raspberry Pi or it can be Arduino or it can be Jetson Nano, etc. Okay. So now let's move to the next thing, which is GPIO's digital pins, right? Sanjit, you can go for Amazon or some purchasing app. You can get it from there. I recommend you to go for Amazon or some sites which is basically selling products only for electronics. So let me check with the sites and let me know you in the tomorrow's class or some other class, right? So which is the best place to buy all the kit, everything, right? So please give me time. Tomorrow I will tell you where to buy all the kit, everything, right? Yes, Balaji, you can ask your doubt and queries, please. Okay. So let's get back to the topic, which is we are going to talk about GPIO's digital pin. So the Raspberry Pi 4 GPIOs are quite similar to what we call digital pins on Arduino board. Those who are familiar with Arduino board, I hope that they get to know about the digital pins, right? So first you need to choose whether you want to use them as input or output. This is the first step. If you configure the GPIO as input, you will be able to read a value from it. Either it can be high or low. High is nothing but 1 or low is nothing but 0. And if you configure a GPIO as output, you will be able to write a value to it. It is also high or low, right? So a digital pin has only 2 states. So low usually means 0 volt and high usually means 3.3 volt. It's some tolerance. So that's very simple. It's like a switch that you turn on and off. So the important thing is that when you set the mode for a GPIO as output, after booting your Pi, you can expect a different default state for different GPIOs. Okay. So let's talk about this important topic about different default state for different GPIOs later. First, let me finish with the remaining pin things, and let us talk about the important thing in later, right? So now, this is all about the digital pins. Now, GPIO's voltage. So, all GPIOs work at 3.3 volt. It's important for you to know that in case you need to plug in a component with different voltage. Sometimes you will find sensors that powered with 5 volt, but all the communication pins are running with 3.3 volt, right? So in this case, no problem. You can use the 5 volt power pin from the Raspberry Pi to power the component, and then use any 3.3 volt GPIO for the communication, right? Simple. If you don't mix the 5 volt signal with the 3.3 volt signal, everything should be alright. Right? If you want to go for 5 volt, just go with that. If you want to go for 3.3 volt, just go with that. Don't mix these both voltage, right? Now, another thing is how to use these GPIOs. See, to use a GPIO, first you need to know its number. GPIO number. As you can see here, the pin numbers and GPIO numbers are different. So pin numbers are in gray. These are all called pin numbers, and the GPIO numbers are in orange color. Right? These called pin numbers. These are called GPIO numbers. So depending on the library you use to manipulate the GPIOs, you will either have to use the number of the pin or the GPIO number. For example, let's say the 29th pin. Okay. Where it is 29th pin, which is corresponds to GPIO 5, not GPIO 29. Not 31st pin is correspond to GPIO 31st. Okay, so 29th pin is corresponds to GPIO 5. So anytime you have a doubt, just check the pin out again and you will know. So to use any of those GPIO, first you need to configure it as output or input. After that you can write to it or you can read from it, right? Okay. See, yesterday and today is just an introduction class. Okay. So let me clear one thing. Yesterday we have talked about the introduction of Raspberry Pi and installation process. Today we are going to talk about the pins overview. First, we need to learn all the basic things. Then only we can go for the programming part. If directly I go to the program and write all the program and explain everything in the sense, you didn't know about the pin everything, right? If I mention the pin, if I mention all the things in the program in itself, you will get a doubt. How to know the pin? How to mention that? For that, you have to know all the basic stuff. Then only you can go for the next thing. So first 2 or 3 days it will be an introduction class. Then there is a 21 days master class, right? So for the first 1 week, it will be like an introduction of everything. You need to know all the basic steps. Then only we can go for the programming part, connection part and hardware part, everything, right? So please wait until then. Huh? Okay. So let's get back to the topic. So see now you might wonder like how can you configure and how you use the GPIOs from your code. So do you need to dive into the complex hardware stuff to do that? Well, there is at least 2 libraries. Note this, there is 2 libraries that will allow you to easily use those pins. For Python, you can use, one is rpi.gpio, and for CPP, you can use like wiring Pi library. You will get to know all about this in the programming part. I will explain each and everything in the programming part. Here I am just giving you the introduction. Okay, so we will talk about detail in the particular session. Okay, so those libraries were developed, so you can use the Raspberry Pi pins just like you would use in Arduino pins. So which means that all the complex stuff is hidden and you can use them with just a few lines of code. All you need is library, that's it, right? So now see this. For example, to set the GPIO 17th pin as output, and I'm going to make it high, what we have to do? Here see, to make two board communicating with each other, it's quite simple. You will configure a GPIO as an input on one side and as an output on the other side. This is how you will make a communication. So you can then use more GPIOs to transfer more pieces of information. Here see, I want to take like pin number 17 as output. So using pin mode, you can make that pin and you can make that pin as output. So this is all about in Arduino. I'm talking about this in Arduino, and this in where? Raspberry Pi. And you can go for digital, right? And inside you can go for the particular pin, and you want to make it high or low. It's your choice. So I want to make it high. This is all about in Arduino. If you are taking Raspberry Pi, there is two options, whether you are going for a pin number or whether you are going for a GPIO number. So if you are going for a GPIO in the sense, we need to mention that library, which is nothing but rpi.gpio. Here you can see with rpio.gpio you can go for GPIO pins. So first that you have to mention that mode using GPIO.set mode function. Inside you need to pass GPIO.bcm. Here see BCM to use GPIO numbers instead of pin number. You want to use GPIO number, not pin number. For that, you have to mention it like GPIO.bcm. Then only it will consider your pin as GPIO, not a normal pin number. And then you want to set to output. For that, what you have to do? Instead, I want to make that 70 IO.out. And then I want to make it. Okay. So, now see this. Communication, okay. So this is the right time to switch your masterclass into 1 month internship on this Raspberry Pi. So if you have any doubts, if you have any queries, you can interact. There is a discount amount which is only for 699. Make your payment. So the last date is 3/5/2024. So make this chance. And these are the projects you will get in this internship, which are smart surveillance system, number plate recognition, eye blink based wheelchair, smart parking system, smart voting system, fire detection using OpenCV, drowsiness detection and driver monitoring, and then face mask detection, which is based on attendance system. And also there is a bundle course, 3-in-1. In this course you will have like IoT, Python and Raspberry Pi. And in this course you will get self-paced 90 records, and there will be a live session for every week, and certification, 20 plus projects and 1 year of validity, and you can download all the presentations. And after registration you will get your confirmation letter, and there will be a hackathon sessions. Actual amount is 2,999, so the discount amount is 1,199. This is the payment link. Use this link to make payment. Am I audible now? Are you able to hear me? Sorry for the delay, there is some internet issue. Am I audible now? So thank you for your response. Sorry for the delay. Here I have some internet issue, that's why. Okay, so sorry. Thank you all for your response. Okay. Okay. So now let's talk about communication protocols through Raspberry Pi 4 pin. So you can use some hardware communication protocols directly with the Raspberry Pi 4 GPIOs. Those communication protocols are in fact the same one that you can natively use on many Arduino boards. So see, with those protocols you will be able to transfer far more information than with just a bunch of GPIOs which is configured as digital pins, right? So on the Raspberry Pi 4 schematics, I'm talking about the schematics, you can see a column for alternate functions. So the communication protocols are all that. So in fact saying that a GPIO, so these are all the alternate functions, right? So let's see one by one. Okay. Okay, so first let's talk about the UART. So UART is a multi-master communication protocol. So this protocol is quite easy to use and very convenient for communicating between several boards like Raspberry Pi to Raspberry Pi or like Raspberry Pi to Arduino. So for using UART, you need 3 pins. One is ground pin that you will connect to the global ground of your circuit. Another one is TX pin and RX pin. Here you can see that UART0TX and UART0RX. So RX, which is nothing but reception pin, receiving pin. You will connect this pin to the TX pin of the other component. For example, there is 2 Raspberry Pi, you want to communicate that 2 board. What you have to do is that you have to connect the TX pin of the first Arduino board to the RX pin of the another Arduino, not a Raspberry Pi board, right? So like that, the RX pin of the first Raspberry Pi board to the TX pin of the second Raspberry Pi board. So TX is nothing but for transmission. So you will connect this pin oppositely to the another board. So if the component you are communicating with this, which is actually not already powered in the sense, you will also have to use a power pin, which is 3.3 volt or it can be a 5 volt to power on that component, right? So by using a UART to USB converter, you can communicate between your laptop and Raspberry Pi with UART. So now, to use UART in your code, you can use the library which is called serial library in Python and wiring pi in CPP. Okay, and then I2C. So I2C is the master slave bus protocol. Okay, so it can have multiple masters. You will mostly use it with one master and multiple slaves. So the most common use of I2C is to read data from sensors and actuate some components. So the master is the Raspberry Pi and the slaves are all connected to the same bus. So each slave has a unique ID. So the Raspberry Pi knows like which component it should to talk to. So for using I2C, you will need 3 pins. One is ground pin. I guess you start to get used to do that, right? And another one is clock pin. So the clock of the I2C, connect all the slaves serial clock to the serial clock bus. And then data. This is for to exchange data between the 2 things. So connect all the slaves data to the data bus. So, and as most of the time, you will need to power on the component. You will also need a power pin like it can be 3.3 volt or it can be 5 volt. So which is linked to the VCC pin of the component. So make sure you know which voltage is accepted by the component before you plug anything. But don't worry too much though. Usually hobby components will accept 3.3 volt and or 5 volt, right? So note that serial data and serial clock pins on the Raspberry Pi are alternate functions for GPIO2 and GPIO3. Okay, so when you use library, Python or CPP, etc. So for I2C, those 2 GPIOs will be configured so they can use their alternate function, right? So some of the best and easy to use library for I2C are, right? And then there is a third thing which is SPI. So SPI, which is nothing but serial peripheral interface. I2C is nothing but inter-integrated circuit, right? And UART is nothing but universal asynchronous receiver transmitter. So SPI is another hardware communication protocol. It is also a master slave bus protocol. So it requires more wires than I2C. but can be configured to run faster. So when to use I2C versus SPI on your Raspberry Pi 4, right? So well, the answer is quite simple. Sometimes see, you will find a sensor that is only I2C or SPI compatible, and sometimes you will just want to have a balance between those protocols. So for example, you will choose to use I2C if you already have many components using the SPI in the sense. So as you progress, you will start to know the difference better. So but for now, let's keep things simple. So as you can see, you get two SPIs by default here. SPI 0 there is and SPI 1 there is, right? So SPI 1 and SPI 1. It means you can use the Raspberry Pi as a SPI master on two different SPI buses at the same time, right? And for I2C, SPI uses the alternate functions of GPIOs. There is the alternate function. So for using SPI, you will need 5 pins. Okay, so first one is ground. Make sure you connect all the ground from all your slave components and the Raspberry Pi together. And then clock. So clock of the SPI, connect all clock pins together. And MOSI is nothing but master out, slave in. Master output, slave input. So this is the pin to send data from the master to the slave. And there is a thing called MISO. MISO is nothing but master input, slave output. So this is the pin to receive data from the slave to the master. Okay, and then chip select pin. So you will need one chip select pin per slave on your circuit. So by default, you have two chip select pin. CS0 and CS1, which is nothing but GPIO 8 and GPIO 7. So you can configure more Arduino pins. So let's make a comparison here. See, we often actually compare the Raspberry Pi 4 pins with the pins from the Arduino boards because to the point where many libraries use the same function name to actuate that pin actually. For example, wiring Pi library uses the thing called void digital write. Inside you can pass the pin number and inside you can pass the value for what? To set the state of the GPIO. So which is exact same function in Arduino to set the state of a digital pin. So it's not quite the same. First of all, our Raspberry Pi has a microprocessor which is often running a Linux system. For example, Raspbian. So while Arduino has a microcontroller, right? So also that's something you can't see on the board directly. So many hardware functionalities from Arduino are not present in a Raspberry Pi board. So you don't have analog pins on the Raspberry Pi board. If you want to use an analog sensor, you will have to use an external ADC and maybe get the value using I2C or SPI protocol like that. So there are no more pulse width modulation pins on Raspberry Pi also. So pulse width modulation are quite useful to control components with a non-binary command, right? You can fake the pulse width modulation pin from software. Example for wiring Pi library, but it's clearly not recommended. Okay, it's much closer to hardware than Raspberry Pi. And thus there are many native hardware functionalities that you can't get on a Raspberry Pi board. So before you choose between those two kinds of board for your project, make sure you know what you need. More computation power, the need to use high level languages like Raspberry Pi or something closer to hardware with limited resource, which it can be Arduino like that, right? Okay. So now let's talk about Raspberry Pi's GPIO's default state. Okay, so you have been playing with your Raspberry Pi and the GPIO panel, and you have noticed that when you read the GPIO, some of them giving you the value like high by default. Some of them give you the value low, 0. Why is that? Here, I will show you what is the default state for each GPIO on the Raspberry Pi, why it's like that. And also what you can do if you want to override the default state. Okay, so to default state doesn't apply. Okay, so first let's define exactly what is the default state. So the default state for GPIO applies like when you boot the Raspberry Pi, when you set GPIO as input, when you read the GPIO state. So when this doesn't apply, so if you added any external pull up or pull down resistor, when you use the function called GPIO cleanup function, so when you configure the pin as output before setting is an input. So these are the things when you apply and doesn't apply. So if you have done any of the previous things, you will have to reboot your Raspberry Pi in order to get the default state again. Okay. Okay. Now see this GPIO's default state for Raspberry Pi. So I provided that you have followed 3 steps and not done any of that. Don't do like that. So see, GPIOs up to 8. I mean 0 to 8. So it will be having default state which is 1. I mean high, which is very close to 3.3 volt. And up to 9 to 27. The pin number GPIO 9 to GPIO 27. It will be having the default state as 0, which means low, which is nothing but 0 volt. Okay. Now, actually this is the example code to test GPIO's default state. Here, yet we didn't go for the IDE part, programming part, everything, right? So if I type the program and run all the things in this, you will get confused how to use that IDE, how to write programs, everything. For that, I have just provided a screenshot of the code. In later session, I will show you, I will talk about the IDE, everything in the later session, right? So for that only, I just provided the screenshot of the code here. So let me explain it. So see, in this code, you can see an array containing all the GPIOs we are using, okay, from 2 to 27. So then we set the mode for each GPIO to input, I mean GPIO dot in, and we read this for the GPIO dot input. Inside we have passed the GPIO. So we print the state. We print the state along with the GPIO number. So see, if we run this program, so for the first time you will get like this. From 2 to 8 you will get 1 and 9 to 27 you will get 0. Okay, from 27, from 9 to 27 it will be like 0, I mean low or 0 volt. And then one thing we do at the end of the program is to call GPIO cleanup function. So this function will reset the mode of all the pins to input. Okay, so to avoid letting some pins as output, which can be dangerous for the Pi, and this will also alter the future state, I mean which will be not be default anymore of the GPIOs in input mode. So if you run this program second time, you will get values like this. Everything will be in 1. So this is because the function GPIO.cleanup was executed during the first program run. So now if you want to get the default states again, you will have to reboot your Pi. Okay, so also note that if you only plan to use GPIOs as input, you don't need to call GPIO.cleanup every time. So this function is only useful when you have GPIO set as output mode. Okay, so another thing is that if you have set your GPIOs to output mode and then to input, there is a chances are that you are going to read 1 for all GPIOs. As you can see here, the default state is only after boot your Pi. So under a certain set of circumstances, then it's quite probable that this default state will be modified in your future programs, right? Okay, now let's see. Okay, why is the G nothing? See here, there is a column called pull, right? So this is from GPIO. This is a column of pull. Here you can able to see from 0 to 8 they will provide like high, and remain everything is low. I mean from 0 to 27. 0 to 8 is 0 to 27. 0 to 8 is high, 9 to 27 is slow. I have already shown you in previous slides. That's why I mentioned again here. You can see here. So this is what they have mentioned in this column. I think it not properly shown here. This is blur. The picture is blurred. So that's why I mentioned here. From GPIO 0 to will be like high, and GPIO 9 to 40 it will be like low. So this value is also the same you found when running the code. High for GPIOs up to 8 and low for GPIO starting from 9. So here high means that is a default pull up resistor on the pin, and low means there is a default pull down resistor on the pin. So when you add a resistor between your VCC is nothing but power supply. So this is a pull up resistor which will make sure that the default voltage you read is close to VCC. 3.3 volt for the Raspberry Pi. Okay, so what this tell you is that for GPIO 0 to 8 there is an internal pull up resistor which will make you read by default. So now what is the value of this pull up and pull down resistor? Unfortunately, it is not possible to know exactly. So the actual Raspberry Pi hardware is not open source. So most of the software is not the hardware, right? So there is no way to know directly from the Raspberry Pi Foundation. However, with some tests published by the user on the internet, we can approximate tell like that this internal resistance is about like 50k ohm. Okay, and now this is the main thing. Okay, so you can convert this masterclass into 1 month internship. So in this internship you will get 90 days access to complete records, and you will get your certificate, and you can download all the presentation files. You will get 8+ project source code. For every week you will have mastermind sessions. If you have any doubts or if you have any queries, you can clear with your mentor, and there is a particular group for internship member, and you will get access to Pantech community, and also there is a career guidance session. Okay, so the discount amount is 699. So you register is 3/5/2024. So use this chance. And these are the add-on project you will get in this internship, which is smart surveillance system, number plate recognition, iBlink based wheelchair, smart parking system, smart voting system, fire detection using OpenCV, drowsiness detection monitoring, face mask detection which is based on attendance system. There is also a bundle course which is 3-in-1. You will get IoT, you will get Python, you will get Raspberry Pi, and in this bundle course you will get self-paced 90 records, and for week you will have the live sessions with your mentor, and you will get certificate, and you will get 20+ projects, and there is a 1-year validity. You can download all the presentations, and after register you will get your confirmation letter, and there will be a hackathon session. And there is a discount amount for this bundle course also, which is just for 1199. So use this payment link to make payment, and the last date to register is 3/5/2024. So please use this chance to get your internship and get your bundle course. Okay, so now let's see the main thing. How to override the default state for Raspberry Pi GPIOs. There is a two things. So see, we have two different ways to override this default state for the GPIOs. You may be fine with the default state, but you could also want to set the default state to something else. All for high and all for low, or you want to a mix of. Using this RPI.GPIO Python module, you can choose to make the internal resistor as a pull up or a pull down resistor for any given GPIO. Here is a sample code. See, to choose what is going to be the internal resistor, you have setup function with either you want to make it pull up or pull down. So GPIO.PUD up, which is for pull up, and GPIO.PUD down, which is for pull down. So if you run this code using this GPIO.PUD, it is 1. If you use the down for pull down resistor, you will get the output like 0. So this is the way, with just one small addition in your code, you can decide yourself of the default state of any GPIO. Right? And there is another thing. which is second thing, which is you can override the default state with an pull up or pull down resistor. So this method requires you to add a resistor to your circuit. For each GPIO is different. So the GPIO for the LED will be configured as output. Right? The resistor is here simply to limit the current that goes through the LED. As we have seen before, the default state issue is only when you read a GPIO in the input mode. So for the push button, you can see ohm resistor between one leg, the same side as the connection to the GPIO and the ground. So this pull down resistor will make sure that when you read the value from the push button, you will get low, 0. So when the push button is not pressed, high means when the button is pressed. When the button is not pressed, it will be in low state. When you press the button, you will get high state. So with this external pull up and pull down resistor, you are sure to get the same value every time. So the internal pull up or pull down resistor is too weak compared to the external resistor. It won't have any effect actually. So in this case, using this option is better. Okay. So the last thing, which is conclusion, what to do? See, each GPIO on the Raspberry Pi has a 50k ohm internal resistor, which can be used as a pull up or pull down resistor in your program or code. And by default, before you set anything, the resistor for GPIOs up to number 8 will automatically be set at pull up. For GPIOs after number 9, which is pull down. So this default state will only be activated after you boot the Pi. So if you use the GPIOs in your code, you might change the default state for any other program you run after that. So the only way to come back to the true default state is by rebooting your Raspberry Pi only. So the first option is to set the internal pull up or pull down resistor in your program. For example, the module, which is the GPIO module. But this option is not optimal. So the value of the resistor 50k ohm is quite weak actually. If you have longer wire, you might experience weird behaviors. Okay. So the best option is to add an external 10k ohm resistor by yourself, either in pull up or pull down mode. So this is a bit more work, but with this you will sure to get predictable and stable results when you read data from a component. So this is all about the pinout session of Raspberry Pi 4, and let's talk about the programming part and simple connection and the IDE, everything in the upcoming classes. So this is all about the today's session. Thank you all. Have a very nice day. Let's catch up at the next topic in tomorrow's class, right?